In Chapter 8, we discussed the fundamentals of measurement in statistics. In particular, we focus on a measurement's validity and reliability. Validity pertains to how relevant a measurement is for representing some property. For example, if you stand on a scale and read your weight, this is a measurement that is a valid representation for your size. However, it is not a valid representation for your intelligence. A measurement is said to be reliable if it is reproducible. These are the concepts that we will discuss in Chapter 8. Like we said, our focus will be on validity and reliability. Finally, we will close the lecture by defining a quantity called the variance. This is a number that allows us to quantify reliability. Let's first define what is meant by measurement. Measurement is simply the act of assigning a number to an individual to represent some property of the individual. The tools used to make the measurement are called instruments. Furthermore, before taking the measurement, we must first choose units in which we will record the measurement. For example, suppose you are the individual we are considering, and the property or variable of interest is your size. To measure your size, we will use a standard bathroom scale. This is the instrument, and our measurement will be given in pounds. These are the units. Let's look at an example from your book. To measure the length of a bed, you can use a tape measure as the instrument. You can choose either inches or centimeters as the unit of measurement. If you choose centimeters, your variable is the length of the bed in centimeters. To measure a student's readiness for college, you might ask the student to take the SAT exam. The exam in this case is the instrument. The variable is the student's score in points, which is somewhere between 600 and 2400. Now, when we assess a measurement, we will always consider the following three questions. First, how is the variable defined? So after we understand that, is the variable a valid way to describe the property it claims to measure? This is validity. And finally, how accurate are the measurements themselves? This is another way of saying reliability. Let's now define what it means for a measurement to be valid. A variable is a valid measure of a property if it is relevant or appropriate as a representation of that property. For example, it is valid to measure length with a tape measure. It is invalid to measure a student's readiness for college by recording her height. Sometimes measurements may be given as a rate, like miles per hour or bursts per year, rather than a count. Let's now discuss the usefulness of certain valid measurements. A measurement has predictive validity if it can be used to predict success on tasks that are related to the property measured. For example, can a student's SAT score be used to predict the student's GPA in college? Can the number of hours one exercises per week be used to predict one's lifespan? Now, anytime a measurement is performed, there will always be some form of error in the measurement. The error can come from one of two sources: bias and variability. A measurement process has bias if it systematically tends to overstate or understate the true value of the property it measures. For example, if a bathroom scale is not perfectly calibrated, then there will always be some bias when measuring your weight. In this case, the scale will always report a weight that is too high or too low. A measurement process has random error if repeated measurements of the same individual gives different results. If this random error is small, then we say that the measurement is reliable. For instance, if you measured your weight 3 times and each time the result was essentially the same, then we conclude that the scale is reliable. However, this does not mean that the measurement is not biased, as the scale may be consistently overstating or understating your weight. Putting these errors together, we see that the measured value is a combination of the true value of some property, the bias in the measurement, and the random error. To quantify the random error in a measurement, we can use a quantity called the variance. The variance is a quantity computed using n repeated measurements. We interpret the variance in the following way. If the variance is small, then we know that the measurement process is reliable. If the variance is large, then we know that the measurement process is not reliable. To compute the variance, we'll use the following steps. First, find the average of the n measurements. We do this by adding the n measurements, then dividing this sum by n. Second, compute the difference between each measurement and the answer to part 1. Then, square each of these differences. Third, average the squared differences from part 2 by dividing their sum by n minus 1. This average squared difference is called the variance. Let's do an example where we compute a variance together. Suppose that your true weight is 130 pounds. 3 measurements on a sticky scale are 132 pounds, 134 pounds, and 131.5 pounds. Let's find the variance of these measurements. First, the average of these 3 measurements is 132.5 pounds. This is found again by adding the 3 measurements and then dividing by the number of measurements, which in this case is 3. That gives us 397.5 divided by 3, which again is 132.5 pounds. Next, we're going to look at the difference between each measurement and the average. So the first measurement was 132, and the average was 132.5, so the difference is negative 0.5. Similarly, the second measurement was 134 pounds, and the average was 132.5 pounds, so the difference is 1.5 pounds. These are the 3 differences. The sum of the squares of those differences is 3.5. So we take the differences found in the line above and square each of them and then sum. So we have negative 0.5 squared plus 1.5 squared plus negative 1 squared, which again gives us 3.5. So the variance is found by taking the sum of these squared differences and dividing by n minus 1, or 2 in this case. This leaves us with a final answer of 1.75 pounds. Just as sample surveys use larger samples to reduce variation, scientists improve the reliability of their measurements by repeating them several times. However, just as with sample surveys, there is no way to eliminate all sources of error. Because of this, the average of several repeated measurements is used rather than a single measurement, as it is less variable. On the other hand, bias cannot be reduced by taking more measurements. The only way to reduce bias is to use better instruments.